All right, so the if statement. We know how the if statement already works. It has a condition, and then if that condition is true, then it displays some code. So it is one of the 3 or 4 forms of flow of control, which includes sequential statements, branching, loops, and then functions, method calls. The book, if I'm correctly remembering, has mentioned these 3. So the AND operator. 2 ampersands means AND. Say we want to print OK if the temperature is between 50 and 90, and not OK if it's outside of that range. So what we want to do? We want to do if the temperature is greater than 50, and if the temperature is less than 90, print OK. Else print not OK. Now this is, I'm going to show you the wrong way to implement this. Now you don't necessarily want to type this. What if we got the temperature, now we have a temperature is equal to sc.next int whatever. And then we did if the temperature is greater than 50, and then we did if the temperature is less than 90, then we print good. Else we print line bad. Else we print line bad. All right, that's perfectly valid logic. But it's kind of dumb. We're printing bad in 2 different places. The only way we're going to print good is if this and this are true. And this is what's kind of known as an if cascade. You have an if inside of an if and inside of an if. If you have an if cascade, check to see if the conditions can be replaced by an and. And if that was true, then what we would do is we would say if the temperature is greater than 50, I'm going to type this in caps, but then I'm going to replace it with the correct syntax. And the temperature is less than 90, then print good. So I'm going to remove that right there. 2 ampersands, the shift 7, represent the word and in this language. And in C++, C#, JavaScript. Python is a weird beast. They actually use the entire word and, which I kind of like. Okay, so there we go. If both of these conditions are true, then this is true. So if you were going to make a little truth table about and, it would look like this. Say you have x, y, and a result. If x is false and y is false, then, or f is true, x is false and y is true, or x is true and y is false, or they're both true. The only time the result is true when you're using and is if they are both true. So this is the only one where the result would be true. The rest of them would all be false, right? Because both this and this have to be true in order for that to be true. So that's our truth table for and. You could rewrite this with zeros and ones. So both of them have to be on, active, for the result to be on. So 0 and 0, nope, that's off. 0 and 1. It's like you have you know, those nuclear missiles that could only be launched if you had 2 people with the keys, turning the keys simultaneously. Unless both keys are turned on, then the missile's not going to go. So that's a false, that's a 0, that's a 0, and that's a 1. So that's the truth table expressed as 0s and 1s. This is the truth table expressed as trues and falses. You know what? T's and F's look way too much alike. Maybe that helps. So typically, if you're checking to see if something is between 2 values, you use AND. What if you wanted to check to see if something was outside of 2 values? You could reword the AND to try to get that to work, or you could use an OR, which we'll hit after a little while. So here's their solution using Java. If the temperature is greater than or equal to 50 and the temperature is less than or equal to 90, print OK. Else print not OK. Now in my logic, I just had greater than 50 and less than 90, which meant that if it was exactly 50, it would say it wasn't OK. And if it was exactly 90, it would say it wasn't OK. So these are what are known as boundary conditions. You need to actually think about and define your boundary conditions. I was somewhat sloppy, and although the problem said it was between 50 and 90 degrees, it didn't say whether that was inclusive or exclusive. You may remember those algebraic terms. Inclusive means that both 50 and 90 are part of the range. And so this is 50 to 90 inclusive. And I'm not usually going to make you rewrite a program just because you made something non-inclusive on its boundaries. But it's something you need to keep track of. So the program on the next slide determines whether the fans win free French fries. If the home team wins and they score at least 100 points, then the program prints this message. So in order to get this to work, we're going to have to know a couple of things. We're going to have to know their score so that we find out if they scored more than 100 points, and we're going to need to know the other team's score so that we know whether they won or not. So let's write a program that asks for those 2 bits of information and then prints, yay, redeem your ticket stub for a free order of French fries. So to do our input, we're going to have an import up at the top, regardless of whether we let NetBeans add the import or we do it ourselves. What's that import going to be? What do we always create in order to read from the keyboard? Yeah, we need the scanner. So underneath our package statement, let's just add an import. Import java.util.scanner. And while we're looking at it, why don't we get rid of that package statement? Now that's going to give us an error that we can fix by either dragging it out of that subfolder or just clicking on the error and saying move class to correct folder. All right, that's good. Then we should put our comment block up at the top with our name, date, and purpose of the program. This is just September 19th's notes. That's enough purpose for me. So, write a program that will prompt the user for our score versus the opponent's score. If we win and our score is at least 100 points, print a coupon for free fries. So it looks to me like we're tracking 2 pieces of information, scores. So I think we're going to need 2 variables, our score and their score. Their team, our team. Score 1, score 2. I'm not sure what to call them. Let's go with our score and their score. So double our score, double their score. Why did I make them doubles? I don't know. Maybe this is a weird game of football where you can earn, 17.5 points or something like that. We could have done ints. So let's prompt them. Prompting is displaying a message telling the user what we expect them to type. Display a message telling the user what input is expected. Without a prompt, it just sits there with a flashing cursor and they don't know what to do. So system.out.println, what did our team score tonight? And let's read that in. What's the syntax for getting, oh, I'm missing something. I can't read anything yet because although I imported the scanner, I never created it. So under our variable declarations here, I guess I'm going to create my scanner. Scanner with a capital S, SC is equal to new scanner, parentheses system.in. Now we can actually get that score. Our score is equal to sc.next double. Then just do the same thing for the other score. Another print statement. What did their team score tonight? And their score is equal to sc.next double. So print line, what did their team score? Question mark. And then their score is equal to sc.next double. Now what are we supposed to do if those conditions aren't true? Just write, too bad? I don't know. The problem doesn't say to print anything if the conditions aren't true, but we ought to print something. So let's write an if statement. If our score, kind of regretting making it a capital S because I keep typing it without the capital S. If our score is greater than or equal to 100, and, so two ampersands, shift 7, and our score is greater than their score, I guess ties don't count, system.out.println, redeem your ticket stub for free fries. Else system.out.println. Hope you had fun at the game. Just to print something. Let's run it. What did our team score tonight? 15. What did their team score? 90. Hope you had fun at the game. What did our team score tonight? 1,000. What did their team score? 1,000. Hope you had fun at the game. Lastly, our team scored 1,000. Their score 0. Redeem your ticket stub for free fries. Okay, so that worked. We've seen the if else in action, and we've seen and at work here. We all good? Let me walk about. So essentially we have a little matrix of conditions that have to be met, right? don't type this. We have to win, and we have to be over 100. So there's four different possibilities. Win could be a false, or it could be true. Over 100 could be false, or it could be true. And since we used and, both of these cases are the only time we'll print that they won any French fries. What if you wanted it either or? Great, we won. Or, hey, we got over 100 points. That's so awesome, we're going to give free fries anyways. We could use an or rather than an and. The symbol for or is shift backslash above the enter key. It's the two vertical bars, like that. So now we would get our free fries if we got over 100 points or if we win, not both. Well, or both. Only one of those two conditions have to be true. I'm going to change that back to and, but I'm going to go back to my notes here and type in a truth table for or. So the truth table for and, both sides must be true for the result to be true. Truth table for or, which is the vertical bars. If one side or the other is true, then the result is true. So false, 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 true, true, false, true, true. So it's like, are you sick or are you tired? In both cases, you get to sleep late. Am I sick? No. Am I tired? No. Do I get to sleep late? No. Am I sick? No. Am I tired? Yes, indeed I am. So I'm going to sleep late. Am I sick? Yes, I am. Am I tired? No. Okay, I'm still going to sleep in late. And am I sick? Yes. Am I tired? Yes. I'm going to sleep in late. Notice the difference between these two. For and, there was only one false. Excuse me, there was only one true. And that was if both conditions were true. For or, there's only one false. And that's if both conditions were false. All the rest of the time it's true. Because for an or, if one side or the other or both are true, then the result is true. So that's something like this. If the temperature is less than 50 or the temperature is greater than 90, print not okay. That's kind of the opposite of what we did with our and. With our and, we did this. If temperature is greater than or equal to 50 and temperature is less than or equal to 90, print okay. We are checking inside the range with an and. To check outside of the range, we're using or. So the OR logical operator provides some code that will print by if the response equals a lowercase or an uppercase q. Here's the pseudocode for it. Now you can't write this, so I wish they didn't even show it. But if response equals lowercase q or uppercase q, print by. So people think that this will work, and it will not. If temperature is less than 50 or greater than 90. It'd be neat if that worked, but it doesn't work. Both the things on both sides of the or the and have to be complete expressions unto themselves. If we surgically remove that, is that a valid expression? No, it doesn't know what it's comparing against. So it has to be temperature greater than 90, not just greater than 90. So regardless of whether you're using and or, the things that are joining have to be valid Boolean expressions. So that means you also can't write this. And I know that we did this in math class way back when. If 50 is less than our temperature is less than 90, right? That looks kind of familiar. We can't do that either. We just have to word it like this. Why wouldn't this work? Because less than requires numeric values on both sides. And you say, well, I see numeric values all the way across. No, not really. Because 50 less than temperature either evaluates to true or false, depending on its value. And then we say true is less than 90. What does that mean? Doesn't mean anything. So the two things you can't do is use or like this. This will not work if temperature is less than 50 or greater than 90. Invalid syntax. Or if temperature is less than 50. Wait. If 50 is less than the temperature is less than 90. That's also invalid syntax. Why am I spending so much time showing you invalid syntax? Because I always get people trying to do this. And some people trying to do that as well, especially when the text shows you that right there in pseudocode, bigger, big as life. So to implement or in logic in Java, you use the or operator. If the response dot equals a lowercase q or the response dot equals an uppercase q, print out goodbye. To compare strings, you have to use dot equals. If you ask the user to type in something that's not a number and you read it in as a string, and you want to compare it to something, you have to use dot equals. So if I do this, print line, what is your name? And then I let them type in their name. Name is equal to sc.next. I cannot do this. If name is equal to Bob, print. Nice to meet you, Bob. That will never work. No matter what they type, that'll never work. In other languages, C++, it might work. No. Here's how you do it. If name dot equals, parentheses, Bob. This is the correct syntax. Looks like I started doing Python here and putting hashtags rather than our comments. Whatever. You know what I was doing. So it's a common bug to forget to repeat the variable. So people try to do this. If response dot equals that or that, that's not going to work. You have to do response dot equals lowercase q or response dot equals uppercase q. Another bug. Use equal equal to compare strings for equality. This code compiles, but it doesn't work. If response equals q or response equals uppercase q. Instead, we have to use dot equals. And we'll learn later on why that's the case. Just accept it. That if you're comparing numbers, you can use equal equal. But if you're comparing strings, you can't. There is a way that you could check to see if something is equal to both the uppercase y or the lowercase y. Along with dot equals, there's equals ignore case. And what that does is it doesn't matter whether it's a lowercase q or an uppercase q or anything in between. So let's go back to our code and add something to it. above the line that says, what did our team score tonight? Let's get their name. String name. System.out.println. What is your first name? And for some reason, we really are curious if their name is Fred. So wait, we have to read it in first. So name is equal to sc.next. Use the scanner class to get our input from the keyboard. So parentheses, if name dot equals lowercase Fred, REFED, or name dot equals uppercase Fred, and I forgot to close parentheses. You have to monkey with it until you get the syntax right. Then we're going to print out something. System.out.println bonus points for being named Fred. But now we're going to use equals ignore case instead. So if parentheses name dot equals ignore with a capital I, case with a capital C, Susan, system.out.println. Susan is a cool name too. So if they don't type Fred or Susan, none of this is going to happen. We're not going to see either one of those messages. Well, we probably will. Oh, I typed some garbage in at some point. Oh, I typed in all those things down here at the bottom I need to delete. Uno momento. Alrighty. So that's our new code from there to there. So I'm going to run it, check my output window. What is your first name? Bob. It shouldn't do either one of those, right? It's not equal to Fred or Susan. It says, what did our team score? What did their team? Blah, blah, blah. Okay, now I'm going to run it again. What is my first name? I'm going to type in Fred, all lowercase, and it says bonus points for being Fred. Now that worked. Then I'm going to type in some numbers just to get rid of it all. Going to run it again. What is your first name? Fred with uppercase letters. Bonus points for being Fred. What did our team score tonight? Whatever, I'm going to type in some numbers. All right, and lastly, Susan. I should be able to type in Susan either in lowercase or uppercase, or even mixed case. Susan all lowercase works. It says Susan is a cool name. I'm going to enter some numbers. I run it again. I'm going to type in Susan uppercase. It says Susan is a cool name. Type in some numbers to get past it. Run it one more time. I'm going to mix my case, lowercase and uppercase. Lowercase s, uppercase u, uppercase n. It says Susan is a cool name. But if I run it and I type in Fred with some unexpected case, like an uppercase F, but then the rest is lowercase, it's not going to match. So it doesn't print anything. Why? Because the only thing we're comparing it to is either all lowercase Fred or all uppercase Fred. We could add a third condition. It's kind of silly to put in 20 different conditions checking for the same thing, but we could throw in one more. We could add on one more or, like this. Or name dot equals Fred with a capital F and the rest all lowercase. But I really should just use equals ignore case rather than try to list 20 different variations of uppercase and lowercase letters. Getting a little warning over here. I wonder what this is saying. It says flip the operands of the binary operator. Invert the if. What? That's dumb. Forget that. Alrighty. Anybody need that code up on the screen, or we all get it? So the not operator. The exclamation mark, when we see it, is pronounced not. It reverses the truthiness or falsiness of the condition. So, for example, suppose, no, we're going to give our own example. We're going to tack on one more if down here. If, but I'm going to put a not in front of my expression. So exclamation mark, name dot equals, ignore case, Bob. Then system.out.println. I guess you're not Bob. So you see what's going on here? It'll only go into this line with Susan if the name equals Susan. It'll only go into this line and print out that message, I guess you're not Bob, if name does not equal Bob. So what happens is this gets evaluated and then the not flips it. So if this evaluated to true, the not could flip it to false and it wouldn't go in here. So if they type in Bob, name equals ignore case is true. But then you flip it with the not and it becomes false, so it doesn't execute this statement which says, I guess you're not Bob. So I'm going to type in Bob. Didn't print anything. That's okay. I'm going to break it, press the little red X, run it again. What is your first name? Joe. I guess you're not Bob. Okay. It is so smart. I'm glad to be told that I'm not Bob. What would I do without the computer? So exclamation mark means not. Reverses true to false and false to true. So if you do this, if A is equal to 100, great. If A was equal to 100, it would print out A is 100. If you did this, if not A equals 100, print line, A is not 100. There's another way we could word this, and it's actually how I would do it. I try to avoid using the exclamation mark in that context because our brains have to kind of do, you know, a little mental gymnastics. Kind of like if you use a double or a triple negative in a sentence and you're trying to figure out, you know, when Mick Jagger sings, I can't get no satisfaction. Is he saying that he can get satisfaction or that he cannot? I've got two nuts going in here. I got the can't and the not. And so anyways, so our minds have to do a little bit of mental gymnastics. And of course, computers don't have a problem with it. They just do exactly what we told them to do. So I would rewrite that like this. If A not equal to 100. To me, that's better. But these two things do the exact same thing. Why would you prefer to do this? I don't know. In that particular case, I can't think of one. But if you're doing that case ignores equals, or equals ignore case, you can't really modify the middle of it, so you're just sticking a not on in front of it. The other thing you can do is to check to see if something is equal to true or false. We could have done this. If name dot equals Bob equals false, then print, I guess you're not Bob. That means the same thing as, let me copy and paste, this, if not name equals Bob. Which one do you like better? I actually kind of prefer the first one, but this is the way that most programmers would do it, honestly. They mean the exact same thing. The switch statement. A switch statement is like a great big if, else if, else if statement. Let's see if I have my code ready, sample problem ready to do this. Well, before I do that, I'll go ahead and explain it. You could write something like this. Print, get a number, enter a number, let them type that number in. Num is equal to sc.nextInt. Then you could write this, if num is equal to 1, print 1. Else if num is equal to 2, print 2. Else if, yeah, you get the idea. Else if num is equal to 3. So we're turning a digit into English numbers. Else, one final else, print error. Apparently this code only likes numbers 1, 2, and 3. We could rewrite this with a switch statement. Switch on the value of the number variable. And in case they typed in a 1, print 1. And then break. In case they typed in a 2, print 2. And then break. And lastly, in case they typed in a 3, then we're going to print 3. And break. And if they didn't type in any of the above, we're going to have a default condition. If none of the above, then print error. That does the same thing as that if, else, if code did above. If I could get them side by side on the screen, I'd be happy, but I know that that's not likely to work. Let me give it a shot, though. Maybe so. So is one of these better than the other? No. But I hope you understand why they're the same. This is just saying if it's equal to 1, do something. Else if it's equal to 2, do something. Else if it's equal to 3, do something. Otherwise, print error. This is exactly what this one's doing as well. Switch based on that value. And based on that value, either execute case 1, case 2, case 3, or print error. Now what do these break words mean? In this case, what it means is go ahead and jump down to the last brace. If we didn't have that break there and the case was equal to 1, then it would print 1, but without the break it would fall through and also print 2. And if there wasn't a break there, it would have fall through and print 3. Not our desired behavior. So what is our program going to do? It's going to ask them for the diameter of a sphere, and then it's going to ask them for what material, whether it's made out of ice, aluminum, or gold. Based on that material, it's going to assign a density. And then based on that density, it can tell us how heavy that sphere would be. So how heavy would a 10-foot wide ball of ice be? How heavy would a golf ball that's an inch thick of gold be? So that's what we're going to figure out how to do. So we are going to need a couple of input statements. Prompt the user for the diameter of the sphere. That's going to be one, scanner.nextInt or whatever. And then prompt for the material, either ice, aluminum, or gold. So let's do that. Well, let's start a new project. This is kind of cluttered now with all this Freds and French fries and stuff. So this one I'm going to just call sphere density. Or you can call it September 19 or whatever you normally like to do. Alright, I know that I'm going to, well, firstly I want to get rid of that package statement, so I'm going to delete the package statement. I'm going to fix that error, which by clicking on it and saying move class to correct folder. Then I'd put my name, date, explanation up at the top. And then I need my import. Import java.util.scanner. Everything lowercase except for the S in scanner. So what are we going to do? Ask the user for the diameter of the sphere. Ask the user for the material. Then we need to do some calculations. Calculate radius based on diameter. And you math fans know that the radius is just half of the diameter, so we're going to divide it by 2. And then calculate the density ratio based on the material. And then calculate the mass. Well, then we got to calculate the volume, and then we got to calculate the mass. So there's quite a few calculations going on here. So if we're going to ask them whether it's going to be ice, iron, or gold, or whatever our 3 choices were, ice, aluminum, or gold, we need to let them know their possible choices. But let's ask them for the diameter first. We need our scanner, so why don't we define our scanner? Scanner SC is equal to new scanner parentheses system.in. And I'm just going to take a shot at defining the variables I think I'm going to need. I'm going to need one called diameter, one called radius, one called volume, and one called mass. And also I'm going to need one for density. And then we just need a variable to store our choice so that we can set the density variable correctly. So I'm just going to call that material. But it's going to be an integer. They're going to type in 1 for gold, 2 for aluminum, 3 for ice, or something like that. So int material. Those are all the variables we're going to need. Now all of these I could have declared on the same line. I could have gone double diameter, comma radius, comma volume, comma mass, comma density. Now we have all of our variables. Let's ask them a question. System.out.println, what is the diameter of the sphere? Now let's read it in. Diameter is equal to sc.next double. Because it might be 0.5 inches, you know. We should probably specify what is the diameter of the sphere in inches. That'd be a good idea. I'm going to take out the words what is, just because I would like to try to get as much of it on the screen as possible. Once we get the diameter, we can calculate the radius, or we could just hold on to that for later. Let's do that. Let's just hold on for later. And now let's offer them their choices. Let's print out a menu of materials. Ice, aluminum, or gold. So 1 equals ice, 2 equals aluminum, 3 equals gold, system.out.println 4 equals, we're going to fill in something later. So I'm just going to put dots there for now, because we're going to come back and we're going to add some more print statements later for other material types other than those 3. Now let's ask them. We've displayed our menu, system.out.println. What is the sphere made of? And we will let them type that in. We're going to fill it into the material variable, and material is an int because it's going to be a whole number, 1, 2, 3, or 4, or whatever. So material is equal to sc.next int. We already have now all the information we need in order to do all these calculations. The only problem is we haven't correlated ice, aluminum, or gold to specific density values. And we could use some if statements for that. If material equals 1, density is equal to 0.3. If material equals 2, then density equals 7, or whatever they are specified in this document that I'm going based on. Oh, I should have made it feet rather than inches. I'm going to go back and modify my prompt to say feet. Why? Because this chart is measuring in pounds per feet. So anyways, ice is 55 pounds per cubic foot. Aluminum is 168 pounds per cubic foot. And gold is 1,200 pounds per cubic foot. And so if you ever think about your fantasy role-playing characters and they find a chest full of gold and they pick the gold up and they run off with it, if it was even a solid square feet of gold, that thing would weigh, more than half a ton. It'd weigh 1,200 pounds. So you'd have a really buff character in order to grab all that gold. Just kind of silliness there. So let's make that change that I just mentioned, or we could, divide by 12 or whatever to get to feet, but I'd rather just do this. The diameter of the sphere in feet. So I just changed that word. And now let's write some if statements, but let's not write some if statements. You know how to write some if statements. Let's do a switch. So first, let's calculate the radius based on the diameter. Radius is equal to diameter divided by 2. That's just how you go in a circle or a sphere. I spelled diameter wrong. And then calculate the density based on the material. So switch based on the material variable. Switch parentheses material into parentheses, curly brace. And we have 3 cases so far. Case 1, it's ice. I'm going to put a comment here for ice. The density of ice is 55 pounds per cubic foot. Break. If they chose 2, that's aluminum. I'm going to have to look that one up. I don't have it memorized. Aluminum is 168. Okay, so case 2. Comment, aluminum. Or as the British would say, aluminium. Why don't the English speak English? I kid. Density is equal to 168. And then lastly, case 3 colon, that's gold. So case 3 colon, comment, gold. Density is equal to 1203. I believe that to be true. Let me pull up my comments. Yep. Semicolon, break. And now we want to default. They chose a material that we don't know. Like they typed 4, Well, we haven't filled in what 4 does yet. So after that last break, default, we're going to give them an error message. System.out.println, and I'm going to slow down and wander around, make sure that y'all are all caught up. Println unknown material. system.out.println, assuming density of 1 pound per cubic foot. That'd be pretty light styrofoam or something. I don't know. And then let's actually do that. Density is equal to 1. That way we just handle the air condition. If they type in a number we don't recognize, at least things aren't going to blow up. To make more of the code fit on the screen at the same time, I'm going to do this, and I don't want you to. I'm moving the break statements up onto the line that matches them. Right? All right, by the time you've gotten that far, you should be able to get it to run. And for those of y'all who do get it to work, I want you to know how to make this calculation. The volume of the sphere is 4.0 divided by 3.0 times pi 3.14159 times radius. And then the mass is equal to the volume times the density. All right. And then print out the volume, and then print out the mass. So I'm going to use two print statements. System.out.println, volume of sphere is followed by the number, followed by a plus sign, cubic feet. But I actually forgot to print out the variable. I just put that, so plus volume. And if your print statements look different than mine, that's okay. The mass of the sphere is, oh, no, I did print out volume. All right. So the mass of the sphere is, quote, plus the mass variable, followed by a plus, followed by the words pounds. I'm going to test mine. The diameter of the sphere, I have a 1 foot ball of ice. Weighs about 57 pounds. Going to run it again. A 1 foot ball of gold. Very heavy. 1,200 pounds. What if it was only 0.1 feet and it was made out of gold? Still 12 pounds. So a golf ball made out of gold would weigh 12 pounds. So what I want you to do next is to go to the instructions, and you're going to see, you could kind of ignore this thing, it just says sizes to try. If you feel like doing a golf ball, it's 0.14 feet. If you feel like doing a basketball, it's 0.8 feet. If you feel like doing a yoga ball, it's 2.5 feet, whatever. But on one page is the C++ code that does this. On the second page is the Java code that does this. But it does it with if statements rather than case. So I'm happy with how we did it instead. But then on the last page are more materials. So remember how we did 1 is ice, 2 is aluminum, 3 is gold? Add some more. 4 is iron, 5 is cedar, 6 is soil, 7 is paper, and 8 is osmium. Osmium is a remarkably heavy metal that's even heavier than gold. It's even heavier than Black Sabbath, man. Such heavy metal. Okay, so let me upload that. And then I'll wander around and make sure that y'all are doing okay. So there's a Dropbox here. If you refresh your Dropbox, if statements and sphere density, at least upload the sphere program we wrote. Also, go ahead and put the French fries program if you want to. But the homework version of it, the instructions are uploaded into Dropbox 6. And that's the one with the extra list of materials. So you can add on, different, you can add on soil and wood and osmium and all of those. So you certainly don't have to complete that now. We only have a few minutes left in the class anyways. So I wanted to do a walkabout, make sure that everybody's got it running. So guys, I got the formula wrong. It's not radius squared, it's radius cubed. So I'm going to do math dot POW radius to the power of 3. So modify your volume equation to look like this. Pi, which we could replace with math.pi. Yeah, let's make this look all professional. So it's going to be 4 divided by 3 times math dot lowercase or uppercase pi times math dot lowercase POW radius to the power of 3. Thank you for catching that. How much does that change my results? Diameter is feet, gold. Okay. Yeah, so that did have a material change in it, of course. Thank you for catching that. That was pretty dumb.